Morning again, grade 8. We are now in the middle of discussion. And let's continue with Bohr's model. I think we're still in the Bohr's model, right, Rabi? Rabi?
Sir?
We are still in the Bohr's model, correct? Am I correct, everyone? Okay. So Bohr
Yes, sir.
took the nuclear atom and dressed it in
Yes, sir.
atom attire.
Yes.
Kept part of Maxwell's theory and borrowed Newton's law of motion. What are the three laws of motion by Newton? Again, what are the three laws of motion by Newton? We have the law of inertia,
Mm,
the law of acceleration, and the law of interaction. During the time of Newton, Newton was considered as the god simply because he actually formulated those laws. Okay? He then proposed the first workable theory of atomic structure. The postulates are as follows. These are now the postulates of Niels Bohr. Number one, a hydrogen atom consists of a nucleus containing a proton and an electron. The electron revolves around the nucleus in circular orbit. There is a force of attraction between the nucleus and the electron. The force balances the centrifugal force on the electron, meaning to say that in a hydrogen atom, it has a nucleus which is positively charged or proton, and an electron which revolves around the nucleus in circular orbit because of because of force of attraction between the nucleus. Remember again that positive attracts negative. That is the force of attraction, which balances the centrifugal force of electrons. Centrifugal meaning the movement in circular motion. Number two, only certain circular orbits are permitted. The energy of the electron in a given orbit is fixed. As long as the electron stays in the orbit, it neither absorbs nor radiates energy. The non-radiating state is called stationary state. Okay, again, if it is non-radiating or if it is not radiating, didn't radiate anymore, okay, it is called the stationary state. Okay. Number three, the electron may move from one stationary state to another. To do so, it must absorb or emit a quantity of energy exactly equal to the differences in energy between the two states. Again, the electron may move from one stationary state to another. To do so, it must absorb or emit a quantity of energy exactly equal to the difference in energy between the two states. Let's have this later, okay? We will explain it more further. Electrons normally exist in the lowest energy, which is called the ground state. Okay? When an electron goes into a higher energy state, it is said to be an excited state. When we say excited state, this is now the state we're in. It is not balanced. Okay? Or it is highly reactive. Okay? Excitation is achieved by supplying energy to the atom from an external source. Okay? In the original Bohr model of an atom, the electrons may exist in any allowed circular orbit. A circular orbit was specified by the whole integer n with values 1, 2, and 3, and so on. This was referred to as the principal quantum number. We are now in the electron configuration. We will be tackling about electron configuration later because it is actually part of Bohr's model or atomic model. Arnold Sommerfeld in 1868 to 1951 introduced the concept of elliptical orbits to explain the splitting of spectral lines. This became the second quantum number to represent the energy sublevel. These sublevels are designated as SPDF. Okay? This refers to as S stands for sharp, P stands for principal, D stands for diffuse, and D stands for fundamental lines in the emission spectra of an element. Let's tackle this later because these are important details. Okay? The main feature of Bohr's model include the following. As the principal quantum number n increases, the orbits or shells or subshells become now longer in radius or increases in radius. Just like your introductory activity. Okay? Your what? Periodic trends. Okay? It explains now your periodic trends. No? As principal number n increases from top to bottom, the atomic radius increases. Okay, from left to right, the atomic radius decreases. Okay, electron in n is equal to 1 orbit shell have the lowest energy. As the value of n increases, the energy also of electron increases. Okay, hence, each orbit can hold the maximum of 2 electrons. Thus, okay, n1 can hold 2 electrons. N2 can hold 8 electrons. N3 can hold 18 electrons, N4 can hold 32 electrons, and N5 can hold 50 electrons. Let's tackle that for that matter later, okay? Because this is under electron configuration. That is why I'm asking everyone to join us in this meeting because this is really complicated and I need to explain this further. Are you still with me? Grade 8?
Yes, Chair.
Okay, how about Rabi? As the atom is being built, electrons occupy the first innermost shell, which is with 1 the lowest energy, before proceeding to the next higher shell or etc. In the electron build-up, electrons must fill each shell to 2n2 capacity. So let's discuss it later. Let's move now to electron configuration. We are now talking about the ground state, not the exciting state or the excite state. Recall that Arnold Sommerfeld proposed a second quantum number which represents the energy subshell. The subshells are given, designation SPDF. Okay? Are you still with me? Now I have only 2 students here left. Each principal quantum number, n, or orbit or shell consists of subshells. The principal quantum number n tells the number of subshells. For example, n is equal to 1 has 1 subshell. N is equal to 2 has 2 subshells, S and P. N3 is equal to 1 subshell of SPDF, and N4 has 2 subshells of SPDF. Each subshell has different electron capacity. as the S subshell can hold the maximum of 2 electrons and the P subshell can hold the maximum of 6 electrons, while the D and F subshells can hold, the D can hold 10 and the F can hold 14. Okay, sure. This is so confusing. Okay. A or S subshell, S can hold up to 2. Duha ra ka electrons ang magunita ni S subshell. Okay? While P, P subshell has a maximum capacity of 6 electrons. Okay? D subshell has the maximum capacity of 10 electrons, and F subshell has the maximum capacity of 14 electrons. Okay, let's tackle about that one later because I have a table here. Okay, this is now the table. Okay, subshell S has the maximum capacity of 2 electrons with 1 orbital. Orbital meaning the orbits. Okay, remember that these electrons are being paired. Okay, moving up and down, right? So since it has only 2 electrons, it has 1 orbital, correct? P has 6 electrons or has a capacity of 6 electrons. Therefore, if you're going to pair 6, you can actually have 3 pairs or 3 orbitals in the P sublevel. Okay? How about in the D? D can actually hold to 10 up to 10 electrons. Therefore, if you're going to pair 10, you can have actually 5 pairs or 5 orbits or orbitals. How about F? F can actually hold the maximum capacity of or electrons of the maximum capacity. We have 14. Okay, if you're going to pair 14, you can actually have 7 pairs or you can have 7 orbits or orbitals. Do you have any questions so far? Questions so far?
No, sir.
Okay, let's have the electron configuration later.
No, teacher.
The way electrons are arranged in the subshell of an atom is referred to as the electron configuration. Chemists use the notation to indicate the electron configuration. Integers 1, 2, and 3 are used to indicate the principal quantum number n. Symbols SPDF indicate the sublevels, and the number in superscript indicates the number of electrons occupying the sublevel. So, the order by which a substellar field by the electron is governed by the Aufbau or Aufbau theory or principle. Aufbau is German for build up. Okay? Okay. This principle talks about that the electrons fill the orbitals one at a time, starting with the lowest energy orbital, then proceeding to the one with the higher energy. Meaning to say that if the orbital is not being paired, so it should be filled up. You know? You need to fill up the orbitals, the entire orbitals, okay, before pairing. Okay, this is now the SPDF. Okay, as if you're going to look at it, let me label it. Can you see? Can you still see my side screen? Grade 8.
Yes, sir.
Okay, let's have a notation here.
Yes, sir.
Start on the notation. Okay. Again, the s orbital. This is the orbital, right? The s orbital can actually have the maximum number of 2 electrons, right? The p orbital has the maximum number of or the maximum electrons of 6. The d orbital has the maximum number of 10, and the f has the maximum number of 14 electrons. It can hold up to 14. That is why. So the movement now is in zigzag motion. Okay. So if this is the arrow, again, from 1s to 2s to 2p, 3s to 3p, 4s to 3d, 4p, 5s to 4d, 5d, 6s, and so on. Okay. 4f, 5d, 6p, 7s to 5f, 6d, 7p. So that is now the movement. Okay. Question so far?
No, sir.
None, sir.
Let's have this example. Let's have this example. How about the electron configuration of okay. Again, S subshell has 2, P has 6, D has 10, and F has 14. How about if you're going to look to get the electronic configuration or electron configuration of the element? Let's have element. Let's check on the element here. Mhm. Let's have the silicon. Silicon has the atomic number 14. Okay. Let's have silicon. Silicon is 14 Si. Let's have silicon. It has an atomic number of 14. How can you get the electron configuration? Simple. Okay. All we have to do is, can you see my shared screen still?
Yes, sir.
Okay. Right. Okay. Silicon has 14. Raise first. Okay. To get the electronic configuration, we must consider also the orbitals. Okay. In the S suborbital, you can actually see that it has the maximum capacity of 2 electrons. So this is 14, right? So 1, S2 because S can actually accommodate up to 2 electrons. By the way, the superscript indicates the number of electrons that occupied in that orbital. Okay, 1s2 starting here. Then we need to move from here going here 2s2 2s2. Okay, 2 because the maximum capacity of the orbital is again 2. Next is 2p. We need to move here. Okay, look at the pattern. It has a pattern, actually a zigzag pattern. 2p. How many is the maximum electrons or p suborbital? We have grade 8. Grade 8, are you still with me?
Sir?
How about
Yes,
Vincent
sir.
EM? Vincent and EM?
Yes, sir.
Okay. How many electrons does your p suborbital contains or maximum capacity? We have EM.
Wait, which one again, sir?
Bilang may maximum capacity.
Of the P, sir?
P is suborbital. We have dalawa.
Seven.
Here,
Seven?
dalawa.
Oh, six.
Klaro na, I already given you the information ahead of time. So since it has the maximum capacity of 6, we need to put 6 here. Because if you're going to total these electrons, 2 plus 2 plus 6, it is still 10. And we need 14. Because the atomic number of silicon is 14. Okay? So let's move. Continue 2p. Next is 3s. 3s. What is the maximum capacity of S? The orbital we have. Rabi? Maximum number of electrons for S suborbital?
Seven. It's
7. S
two,
suborbital.
teacher, two. Two, sir, two.
It's 2 here. Okay? It's in here. So we need to put 2 simply because if you're going to total it, 2 plus 2 plus 6 is 10 plus 2. We still need to occupy a lot of space because it is still 12 and we need 14 because silicon is 14. Correct? So we are done with S. Wait. We are done with S. Let's continue. It's 3S, right? Okay. It's 3S, right? This one, we are done with this. So let's move in 3P. Okay. This is 3P. 3. Can you see my shared screen?
Yes, sir.
Okay.
Yes, sir.
We are still in 3P. So we need to write 3P. How many is the maximum capacity of 3P or P?
6.
6. But since we only need 2, because if you're going to put 6 here, I'm going to write 6 here. Tendency is, if you're going to count this one, is 2, 4, plus 6, 10, plus 2, 12, plus 3, plus 6, 12, plus 6 is 18. Okay? But we only need 14. Okay? Because the atomic number of silicon is 14. So what will we do? Since we only need 14, okay, we will not write 6 there. Instead, we will write what? This is 12 already.
2.
2, correct. Because we only need 2. Okay. So, the atomic number 14
Four-
silicon has this
14.
electronic configuration or electron configuration. Okay, 1s2, 2s2, 2p6, 3s2, and 3p2. Okay? Following the Yun's rule and the Aufbau principle. Okay? Now, talking about the Aufbau. Sure, what does it mean? Okay. In a 1s2, okay, 1s2, it means that it has two electrons occupying in the what? In the orbital. So if this is your orbital, so only one box because only one orbital, right? So the electrons are moving up and moving down. That is actually the representation of 1s2. Okay? 2s2 the same because it is in S. How about 2p6? In 2p6, 2p6, you can actually have how many orbitals are in P? We have 3. Again, remember that these electrons are being paired. So the 2p6 has this representation. Sure, why are you writing or filling all the boxes? Because according to Aufbau principle, that you need to occupy the entire what? Entire orbitals before proceeding to pairing. That's the Aufbau principle. So, you need to put again the arrow down to fill up the, okay, that is actually 2p6. Okay, how about 3p2? Since it has only 2, sure, how can you write this one? This has only 2. Okay, 3p2 would look like this. Again, p suborbital has 3, right? 3 orbitals. Okay, how do you write 3p2? Simple. 1 and 2. And that's it. Because it only occupies what? Or it has only 2 electrons in it. So you need to scatter it over. Sure, what is the resemblance or what is the importance of knowing the electron configuration? Okay, talking about this 3p2, this will give you an idea where your element is located in your periodic table. Like for example, silicon belongs to 3p2. Okay, let me share my screen just to give you an idea. Actually, I included this in your, okay, let me share my screen. Okay, okay. So, your element silicon belongs to 3p2. Okay, let me share this one. 3p2. Okay, can you see my shared screen?
Yes, sir.
Yes, sir.
This is 2p. This is 3p. Okay, this area here is 3p. So, 3p2. So, 1 and 2. So, the silicon belongs here. Okay, 3 and 1, 2. 3p2 here. Okay, let's check on our periodic table if it is correct. Okay, let me share my periodic table if it is really true. Okay, 3p 1 and 2, it's correct. Silicon is in here. Correct? Question so far?
No, sir.
Okay. Let's continue with the discussion. We still have
No, sir.
how many minutes? It's 2 minutes more. Those are the way we actually can get our electron configuration. Okay? I will give more examples by next meeting. Let's continue by next meeting since we only have 1 minute left and this may cut off a little bit. Alright?
Okay, sir.
I think that will be all for today, class. Hopefully, you learned something out of our discussion. And we will have more examples by next meeting because this will come out in your major exam. And your major exam is fast approaching. Let's make it hurry. Okay? We have a lot of things to do, even activities to do. Right? Grade 8.
Okay, sir.
I think that will be all for today, class.
Okay, sir.
Thank you for your participation, Vincent, EM, and Rabi. Have a nice day, grade 8. Goodbye.
Bye, sir. Thank you so much.